All right, so now that we can see that 187.9 is what giving us the 230.129 is not exactly giving me a 230. That's mainly because of the rounding errors and whatnot. And again, putting in a 187.9 is not that intuitive because there's a line to ground peak voltage. So I want to be able to set this up so that our initial calculations where we took the 230 divided by root 3, we got 132, and then we multiplied that by root 2 to get this number, because that's what we need to enter into the or that's what we need to enter into this field here, as per how that's the Pscad is set up. So, but if I want to be able to do something like this, I want to be able to set maybe a 230. Perhaps what I'll do is first I need to I'll set it to a numerator and denominator um, block, and in that denominator I'll put a root 3, and then I will, rather than take a multiplier and then I'll multiply it with a root 2, so that will give me 187, and then we will feed that into the voltage. But at the same time, instead of providing this as a fixed constant, maybe what I could do is I'll probably throw a signal which we will call voltage line to line underscore RMS, right? And then that signal will then be fed from perhaps a slider, okay? A slider where we can set it by default at 230, but we can make it go up or down. So we can then have this automatically change and go into our voltage source. And then at the same time, that particular slider then would need a control panel where you would be where would be controlling the voltage. So let me quickly show you how I would do this. So I'm just going to move this. I'm going to get rid of this entire. So let me just stop the simulation here. I'm going to get rid of this. I got to go into master library, and all I just need is just the multipliers and then the dividers. So if you kind of come down here into right there, more on CSM functions. So you can see, I can kind of pick it up right from this page. These are the two that I'm looking for. So I'm going to take this and that, bring it back to my case right here. So initially, what did we say? We said we're going to have a numerator and a denominator, right? So if you could see right here, what do I have? Like that. So I'm just going to take this, and then now what we will do is uh, what I'll do is maybe I'll take this out. I could put it at 1.73 or something like that, if I wanted to put it as a root 2, but I wanted to put an actual root 3 in the denominator. So I'm going to go into master, and in master, if you come back out and right over here, miscellaneous, come in here and you see right there, this is just called common constants or built-in EMTDC constants. So what we're going to do is we're going to just take this, bring it over here, and these are just the constants, and the good thing is we can kind of use the slider, and then the drop down menu, we're just going to pick a square root of 3, and then I need to multiply it by the square root of 2. So I got to come back here, choose a square root of 2, and then what we can do over here is like this, and then we can just kind of go right in like that. And I'm just going to reconnect it like this here. Okay, all right. Okay, so now in this case, I pressed the Control Z, which kind of messed up my values here, so I just put them back. All right, so coming back over here, so now you can see how we have achieved the numerator denominator. I'm multiplying by root 2. I got the root 3, and over here, what value do I need to pass down? Now I could. What I meant was if I were to just put a 230 here, like this, yes, it will give me a 230 in here, but I would be the same problem where I won't be able to dynamically change this value. So it made it a little bit more intuitive where we understand this is 230 and doing all these different calculations. We're not seeing 187, but still it's not very helpful because I can't really change it during the simulations. So I want to be able to pass a signal. So I'm going to kind of do something like this. So now I'm passing the signal into the numerator, and I'm just going to name this voltage underscore, let's say, line to line underscore RMS, and perhaps I can just name it source as well. So it makes it a little bit more intuitive. So just like that, copy it like this. And now what I want to do is I want to be able to set a slider that can then change these values. And anytime when you have a slider, you can name this as well. We can just say uh, we can just name it exactly like that if you needed to. The name doesn't really matter that much for these sliders. It doesn't play any role in compiling or getting calculated, or it's not looked at by the Pscad. It's just for our ease. Now, in order for us to make the slider work, you need to have a control panel, and you got to click it and then Control C and then drop down into the slider. And let's set the edit properties. Sorry, so you could see when I did the properties, it kind of showed me control panel settings, because you actually need to click inside this right here. So because you can have, for example, I can have multiple of these under the same umbrella. So you have to, so I'm going to delete this. You have to make sure you're clicking right in, and then I'm going to say, okay, let's do the settings for this slider here. And this slider, what I want to do is, I'm just going to say, hey, you know what, up to 500 I could do, but initially when you start, I'll start at 230 because it's easy for me to, every time you're going to open a Pscad model, it's gonna have a value of 230. So let's run it now and see whether we still how we can make the voltage go up or down while the simulation is running. So let it load for a bit here. So it's compiling. Now it's finished compiling here, right there. So it's about to run. So it's thinking. There we go. So right here, voltage line to line RMS, which is now getting picked up from this this voltmeter here, or this multimeter here, and you could see it's all nice and clean to 30, not a 230 point something something, but an actual 230. Now if I can make it go, you can kind of make it go up to like 300, like that, and then you will notice that it will go up to 300. You can even use these buttons to make it go up. You could do that as well. Then it will kind of pick up, these little steps that was used, or you can directly make it go up to 500, and then it will go up to that, and then we can actually make it come down to, let's say, 100, and it will allow us to do that. So this is the dynamic control, and now we have a voltage source, which is a little bit more easier to utilize. But if I had just shown you guys exactly this, you may not have fully understood as to what all of this means. So I thought maybe I'll just kind of go step by step to explain what this is happening, because it's not very intuitive to have 187 point something value going into this V, and not being able to change it also is fairly annoying at points, depending on what type of a study you're performing. So I hope that helps, and we'll see you in the next video.